Alright, so in this unit, we're going to first talk about looking at who, what, when, so in a sense, this is the different definitions, getting some terminology down, and talking a little bit about how sampling is actually done. So our first video in this unit is going to be talking about data. So the first one we're going to talk about is what is data. So data is defined as values, and this can be both numeric or non-numeric, with context and meaning. So, and this with context and meaning is an important part. So for example, I don't want just numbers. I need to know what those numbers mean to me. So when we're going to want to collect some data, the first thing that we need to know is why do we want to collect this data? So what do we actually want to know, and from who do we want to know this about? So our first two definitions are talking about a parameter versus a statistic. And these are actually a pretty similar definition, just a small difference between them, so we'll make sure we emphasize those as we go. So a parameter is a numerical summary of the population. Whereas a statistic is a numeric summary of a sample. And so, of course, the difference between these two are where they're coming from. So a parameter is from a population, and a statistic is from a sample. And so what you'll notice here, right, is that parameter starts with P, so does population, statistic starts with S, and so does sample. So it's kind of an easy way to remember which one is which. Now, we're of course going to talk about the difference between a population and a sample, and we can actually do that real quick before I give you an example of each of these. So then, of course, what I want to know, what is a population versus a sample? So to understand that, we're going to go down here to who that we are talking about. So what information from who do we want to get these observations? So our first definition here is what's called an experimental unit. And these are the individual elements that the records come from. So there's a lot of times is a person, but of course it can be an object like a plot of land, for example. It could be an animal. So there's lots of different things that I can collect information on. The population consists of all possible experimental units of interest, whereas a sample consists of those that we've actually collected the data on. So the population is the entire group I want to know about. The sample is the ones that I just collect data on. So going back up here then to parameter and statistics, some examples of them. So first of all, it's a numerical summary. So for example, I might be calculating the mean height of people. That's the numerical summary. But of a population, so maybe my population is all NKU students. Versus a numerical summary of the sample or a statistic, I'm still going to be calculating the mean height, but it's just of those that I collect data on. So maybe I collect the heights of just those students that are in our class. Right, so I want to know about all NKU students, which is my population, but I only maybe took a sample of those people that are in my class, which then of course would be NKU students. So we have the first idea talked about, okay, who do we want to know information about, and what do we want to know? Like, right, so we know why we want to know it, we know who we're collecting it on. Now, what information do we need to get in order to actually answer our question of interest here? So the first thing we need is what's called a variable. And this is the information that we collect on an individual experimental unit. And it's in part that the individual part is important as we go. A lot of times students will begin to think of a group instead of just that individual. So kind of thinking about what's being asked of like me individually when I'm trying to talk about what the variable is. And then there are two different types of variables. There's what's called a categorical variable, or some people refer to as what's called a qualitative variable. And then there's what's called a quantitative variable. We like to use categorical instead of the word qualitative for a couple different reasons. One, I think it's nice because it's an easier auditory difference between categorical and quantitative than there is between qualitative and quantitative. So it's just easier for students to hear the difference when I'm talking. But secondly, the term categorical makes it a little bit easier to understand the definition, because a categorical variable is a variable whose responses consist of categories. Versus a quantitative variable is a variable whose responses consist of numerical values but more specifically that quantify or measure something. So we'll go through a few different examples of some variables and figure out where those go. Alright, so for our first example, we'll kind of start easy here. Is looking at gender. So gender, my options are male and female. So that's going to be a categorical variable. Versus, I'm going to start with another easy one. Let's look at age. Age is a number. It does quantify something. It measures something. In that sense, it has years that we have for our units between it. Another example we could talk about is race. Alright, so race kind of has our category options there, so that's going to be a categorical variable. Versus we look at, for example, height. Height is measured in inches. Alright, so it does quantify or measure something that we have there. Let's talk about, how about area code? Like the area code for your phone number. So this is one that's a good example to talk about because area code is a number. However, it doesn't actually quantify or measure something, right? There's no units attached to that. And so actually what area code tells you is geographic location, which is technically a categorical variable. So let me help define a little bit better than what I mean by quantifying something. So when quantifying and measuring something, if I look at comparing those two numbers, that difference between them means something to me. So with area code, the example I like to give is that I'm originally from Nebraska and my area code was 402. I moved to Kentucky and my area code is now 859. So my area code more than doubled. But right, that doubling of my area code, that quantifying that number doesn't actually mean anything to me. Right? All area code does is tell you that I moved from Nebraska to Kentucky. So it's actually not a numerical measure that I'm worried about. Alright, so those are the 3 things we always have to know is why we're collecting the data, who we're trying to collect that data on, and what information we need to get from those. The other things we would like to know, if we can, is to know where we're getting the information. So looking at salaries in the United States, for example, will be very different than those in Mexico. Knowing when, so knowing the possible time frames. If I'm looking at older data from 2005 versus newer data from maybe 2015, I want to know that when I'm looking at it. And of course, I'd like to know how someone gets their data, and that's one that we're going to have to talk about quite a bit. But we'll talk about a few examples before we do that. But so, if I wanted to get salaries, how do I get salaries? Right? Do I ask people their face? Do I go to HR? So how are we actually going to get that data? It's an important thing that we're going to talk about as well. But first, before we dive into something new, let's actually do a couple of examples that help us apply some of these definitions that we've used. So for our first example here, we're looking at estimating the mean age of all undergraduate students at NKU. So I took a random sample of 100 undergraduates at NKU and got their age. So what is our population? So our population is the entire group that we're interested in studying. So if I look at what I have here, we're interested in looking at all undergraduate students at NKU, right? So that is my population. I'm not interested in the faculty, I'm not interested in graduate students, I'm only interested in undergraduate students at NKU. Then we want to know what variable we're collecting, and then we want to know if it's quantitative or categorical. So if I have an undergraduate student at NKU in front of me, what information do I want to get from them? Well, it says I'm looking at recording their age. So age is the variable that we're interested in. And just as we talked about, this is a quantitative variable. Right, we have units, it's in years when we calculate it. A difference of two numbers means something to me. What is our parameter? So our parameter, remember, is a numerical summary. So it's a number that summarizes from my entire population. So one number to summarize the entire population. So the first word I'm going to put here to help distinguish it between the statistic, which is number 4, is that we're getting something from the population. What number are we going to get from the entire population? Well, we want to know the population mean age. Now the statistic of interest is, remember, a very similar definition to parameter. It's a numerical summary, but it's where it's coming from that's different. So a statistic comes from the sample instead of the population. So my first word here will be a sample. And what number can I get from my sample? I can also calculate the sample mean age. Now let's go ahead and talk, just kind of use the idea of using a formula sheet and knowing some symbols. So one symbol that we actually have is the Greek letter mu that we saw in the normals notes. And this is for a population mean, or the population average. So if I have actually a sample mean instead, I like to have a different symbol so I know when I have the population versus just the sample. So the sample mean is read as Y bar, that's how we read that. And that's just our sample mean. Right, so we did example 1 together. I would just go ahead and pause it here, maybe try example 2, and see if you can identify the population, the variable, the parameter, and the statistic, and then unpause to see if your answers match mine. So here's what I got. Since we're looking at estimating the percentage of Americans, I'm looking at my population being all Americans. So compared to example 1, this is a much more vague population, right? All Americans. So technically a baby that was just born here in the United States is an American. It's also much bigger than the one that we had before. So right, a population can be very, very big or very, very small, depending upon what our goal is and who we want to know about. The variables, if we have an American in front of us, what do we want to know from this person? Well, I want to know if they approve of the president right now or not. So it's kind of a yes-no question. So do you approve? And then since it's a yes-no answer that we have, it's going to be a categorical variable. So when I have something that's categorical, and then looking at a parameter which is a numerical summary, it seems a little weird. This is where, again, remembering that a variable is collected on an individual, versus when I'm talking about the parameter and the statistic, it's a number that summarizes all of that group that we're talking about. So if I have a whole bunch of yes, I approve, no, I don't approve, what I can do is calculate then the approval percentage. And so for the parameter, that's going to be the population approval percentage, or the percent of all Americans who approve of President Trump, versus the statistic for the sample approval percentage. Now, since these are different than the ones that we talked about before, they do actually also have different symbols. So we're not calculating a mean anymore. So P represents a population proportion. And a proportion versus a percentage, a proportion is just the decimal form of a percentage. So for example, if you had a 50%, your P is just 0.50. So it's just that decimal form of a percentage. Versus we call P hat is how we read this one. That is our sample proportion. And these are some symbols that you're going to see later in this unit, is this P and P hat. So some questions for you to kind of see the idea of where we're going to be going with this. So if for this example, we each sampled 1,000 Americans, right? We each go out, find 1,000 Americans, ask them if they approve of President Trump right now or not. Let's see how you'd answer these questions. Would we each have the same value for P hat? So we all have the same sample approval percentage. Whereas if we ask different people, we're probably going to come up with some different values for P hat, right? So I might find 45% of my people approve. You found 49% of your people approve. Right? So we could have different values for P hat. So thinking then a little bit further, would we each have the same P, or the same population proportion? What do you think? Here, that answer is actually yes, because we all have the same population. So that population percentage isn't changing regardless of who I sample. So we all have the same goal that we're trying to do, but we're taking different samples. So think about a similar idea as if you've ever seen like one of those games, right? Guess how many jelly beans are in the jar. Right, there is a true number of jelly beans in that jar, right? Basically a true population value. But we're each going to come up with different guesses. But we're all trying to estimate the same thing. So sort of the big takeaway to remember here then is that parameters, which again are our population values, are fixed, they don't change. However, statistics, or our sample values, vary based upon the sample. So this is a nice introduction into terminology. Next, we'll talk a little bit more about how we collect some data.